Okay, now it's a special moment. We have never done this before. We are basically ending the conference with the most important guy in the room, rather than starting it. Come to me, Pedro. Come to me.
Thank you.
We
Good
take
afternoon,
a
ladies and
photo
gentlemen.
together. This is one of the reasons.
I like your shirt. I like your shirt.
Yeah,
it's
blue,
not green, it's blue.
Yeah,
I like it. Light blue.
It says Amsterdam.
Yes.
And that's where we do a conference next year.
Very good.
And this is Pedro Miranda. Let's take a photo.
Yes.
Okay.
Thank you.
And you are actually the host here. Yeah,
Yes.
this
Yes.
is your office here, this
Yes.
building.
Yes.
Tell us a little bit about this building and why Siemens created the crystal and what is happening since you launched it. Tell us about this place.
So first of all, thank you again for having me. It's a big pleasure and honor to be here. So I think after 2 days, I think you were here 2.5 days, you have already a feel what the crystal is. It's one of the most advanced buildings in UK and also in Europe. It's also highly efficient. So we, in terms of eco efficiency, we use 50% of a normal building compared with other office buildings in London. So it's a very advanced. We have close to 3,000 sensors, which you probably don't see, but they are acting. And we have an average of 1 sensor per 2 square meters, which is one of the highest in the industry. And we wanted to have this as a showcase for our customers, but also to our partners and to our employees. And this has been visited since we opened 3 years ago by 250,000 people, which is a record inside our company. So this is the biggest showcase we have in Siemens worldwide, a permanent exhibition. And it's also the largest urban sustainability exhibition in the world. So I hope you had time to look at some of our, let's say, innovations since we opened. I think you saw the digitalization table. We are now thinking about bringing the Industry 4.0 exhibit. So I think we have a lot of things still to go in the future. But so far has been a very good story for us. We are very happy with the investment. We had an investment of £50 million when we start this thing from scratch.
Mm-hmm.
And the whole company is super happy that we made that investment, and now we can also build on it. The customer response is very good, so we have basically a lot of customers coming from all over the world to London, which is a very nice place to do shopping and other things too. So we attract Americans, Australians, Middle East customers, but also from Europe, from Scandinavia, also from South Europe. So it's for us a very, let's say, different investment from what we do at Siemens.
Mm.
We have 300 plants all over the world. And this is the only one which is not a plant, but it works like a plant.
Yeah, a factory of ideas.
Yes, yes.
Great. And do you recommend to other corporates to adopt and follow your example and also create technology, showcase buildings, because it's nice to have a super advanced building? Is it something that other corporates should do too?
Well, I think every company has its own, let's say, strategy. So we can recommend because it's a good investment. Yeah. For example, we have here a technical tour, which you can order a week in advance, where we show you all the specifics of the sensors and how we treat energy, how efficient are the rooms, and so on and so on. So it really depends if the corporate world is moving in this direction, but they are. We are moving in an eco-business environment all over the world. So low carbon industries, low emission cities. So I think this eco idea and the Ecosummit is a big boost for these ideas. It makes sense. It makes sense for us as a company, but also makes sense where we live.
Cool. Okay, let's have a presentation from you now.
Yes. So again, it's an honor to be here for the 3rd time in a row. And my first presentations 3 years ago were a little bit technical, so I thought this time I would go a little bit more in a broad vision of what we think at Siemens is the power of digitalization in our world. And one of the topics we love to talk about now is actually the cloud computing. So cloud computing is really the backbone of future information technology. This has changed dramatically. And we have now 50% of the enterprises using hybrid clouds in 2 years. That means in 2017, 50% of all the big corporations will use hybrid clouds. And most importantly, is 90% of all of the organizations will store personal IT data in databases that they do not own. This is also an innovation, technology innovation. That means you're putting data outside your control into the cloud. And in 2020, that means in 5 years, we expect that no major corporation will have its own IT department. Everything would be, let's say, at the cloud level. And we have here a development of today, where we have integrated edge devices, as you well know, going into marketplace for resources in 3 years. And in 5 years, we expect to have cross-domain applications between clouds. So that means really big data being transferred cloud to cloud instead of user to cloud. And this brings a lot of challenges. And the challenge is how to manage data. Because the IT systems per se, they don't have a lot of value, but data has a lot of value. And we think about 1960s when we had the first database. I think some of you were in college, some not. But we had the first databases with large computers occupying huge amounts of space. And we moved to the late 80s where we had data warehousing. This was something which was also a jargon. And we had relational databases. We moved then to the early 90s with artificial intelligence and data mining. That means we were able to mine data, specific data. So this jargon, data mining, is already in our heads because we use it a lot still. But this is gone. We don't do any more data mining. What we do is big data analytics. This is the big development in the world around data, where we have massively distributed stream processing of data. And this has a huge amount of data to be sorted and to be correlated and to make it smart data. And some of my slides in the future will show you how we're doing this. So important is that cloud is here to stay. In between cloud communications will be the future. And this has to do with the huge amount of data that we have now to process in our lives. The other trend on data is regarding mobile applications. So everyone has a mobile device. We think that the user base, that means with mobile phones or apps, will exceed 5 billion users. 5 billion users. This is unthinkable because each application in each device will then have the triple applications that we have today in the next 5 years. So more apps are coming into the market. And 87% of the worldwide computer market will be based on handheld devices like tablets and smartphones. So this is a huge change. And whatever we do in our businesses, be it engineering or services, this will come in a big way. Mobile applications are here to stay. And of course, this also brings a lot of complexity on the devices itself, but also in the infrastructure. And you can pick whatever application you want, but it will be always very complex. So the world is getting, in terms of data processing, in terms of getting smart data out of the devices, much difficult. And for us, Siemens is a huge opportunity to capture that. And why is this important? Because data on itself is not a value, but money is the driving of the economies. And there is a study from the UK government that estimates that 20 pounds of economic value is delivered from £1 investment in digital infrastructure. So the leverage between is 1 to 20. So every time we do an investment in digital infrastructure, we have a return or a potential growth of 20. So this is never seen before, and this is why there are so many companies working in this area. Secondly, MIT, Massachusetts Institute of Technology, say that the big corporations or the companies which use data-driven decision are 5% more efficient. And that makes sense, but this is, let's say, a study, a profound study they did, and it shows that big companies have to be very close to this action. And last but not least, for example, in the healthcare budgets, using big data could save $0.5 trillion in healthcare services around the world. So we have an economic value associated with data, and we have also a trend of the consumer behavior, which is using more applications on devices. the smart city market, we have to sometimes give these numbers, some numbers are too big to comprehend, but they are really huge numbers. Frost & Sullivan said that the smart city market in 5 years is worth $1.5 trillion. All these applications around, and I'll talk about this in the next slide. McKinsey said that we would need in the future, going to 2020, about $57 trillion to fuel global development in cities. And last but not least, Siemens, we have identified that digitalization in cities grows our market between 7 and 9%. So it's not double digit, but it's very high compared with automation, which is 5 to 7, and electrification, which is between 2 and 4. So the future of IT for us is about smart solutions. I think smart is something that everybody uses. I have a smart car, I have a smartphone, but it's really important because smart brings a lot of power to what we say, and it brings a lot of data. And examples are smart cities. That's the area where we work here at the Crystal with my colleagues in the Center of Competence, where we work about resilient cities and CO2 emission reductions and so on. We have the smart grid, which is a turf, which I will talk later on for my colleagues in electrical engineering, how to bring the grid into the new environmental friendly production. Smart mobility is very important. People want to move smarter. And last but not least, living and health, which are something is a no-brainer, but it's really important. So what are the research fields at Siemens on the Internet of Things? So we have 4 pillars. This is where we are an industrial company. So we work on the Web of Things. And this is very important to work with smart distributed systems. We also work on a plug-and-play automated distributed system, which we call massive distributed systems. I show you how this means in terms of products and solutions later. And we work on embedded systems. And embedded systems are also the ones which are embedded in the networks of systems. And not last, but very importantly, the industrial communications. So we need to make sure that this huge amount of data is transferred from devices to analog filters, and from that we derive our conclusions. So let's see what is the smart data business principle at Siemens. So we are not a small company, so we make concepts, we produce, we deliver, we install, we commission, we service. And we have 3 domains which are very important for us to make smart data. One is domain know-how of the vertical. That means in this case a power plant. So we know what the power plant does, what is the efficiency, what machines they use, and so on and so on. We have a device know-how, so we know about the architecture and the communications of devices. So it's not only the vertical domain, but also the device understanding, which is very important. And last but not least, we know how to analyze data. So these devices come from our vertical domain, we analyze it, and from that we derive smart data. We derive smart data not only for us, we derive smart data for our customers. Because customers say, what should I do? And we say, well, you should do that because of this, this, and that. So our model is to look into the technology of domain know-how of the vertical, together with device and the data analytics, which I've talked about. And then it could be thousands of devices being fed into a system, and we have to analyze. For example, the Crystal, we send all this data from these 3,000 sensors to Frankfurt, where we have a specialist group which takes a look at the analytics. And we get every day a report on what we are not doing correctly at the Crystal. You should do that, you should change your opening of the vents, all this stuff. So this is an example in buildings which, we send the data to Frankfurt because that's where we have our, let's say, worldwide data analytics for buildings. And this is done automatically, and we get a report every day. Just imagine if you have hospitals, if you have stadia, if you have large infrastructure, and you can use the power of data, so you do not need to have engineers here, which are specialists, because we have this remotely, and we can use the data online to get information and to get also actions. So in terms of smart city, because this is what we do here at the Crystal, and in the end, the IT part connects all the parts. So no one in a city is now, let's say, away from IT. Everything is connected. An example, grids talking to buildings. We have also renewables getting into the grid. You have smart transportation. You have decentralized energy systems. And these are the topics that we at Siemens work. We work with data, with domain, know-how, and try to get the best models. I have some examples for you in the next slides. How can this be a benefit, not only for the user, but also for the city? One of the topics of cities is that the challenges. I'm not going to say again that people move into cities and they live more in cities than in rural areas, because that's a no-brainer. Everybody sees more people coming into cities because it's easier to live, it's more attractive. There are schools for kids, there are universities for grown-ups, there is hospitals, there is Medicare, Medicaid, all this stuff. But the challenge is, how can we move more people? Because people move into cities, and then we have a prognosis by 2050, 3 times more traffic will happen in cities. 3 times, from now to 2050. So how are we going to solve it? Secondly, there will be more renewable power being produced than today. We estimate that in most of the cities, the energy grid will be something like 30 to 35% renewable energy. So, as you know, photovoltaic and wind are very fluctual technology, so we cannot have a steady state supply of the grid. So how can we solve this? And last but not least, energy is going to be more expensive, because renewable energy is more expensive to install. Even if you don't like to hear that, but this is reality. It's actually more expensive, so the payback period is much longer, so you have to be smarter and consume less. Otherwise, the business model does not work. And if you look into the left and you go to the right, so then there are solutions. And some of these solutions that we have developed are, let's say, a no-brainer for some. But for example, in Taipei, we put a la crystal type of system. That means in terms of room comfort and building automation, and they save close to $700,000 per year in the building operation. So if at the end of the day you have $1 million, which is payback, then the investors go in this direction. It always has to be economic value. Without economic value and without a timeline, the investors will not put the money in. And of course, the future grids is also a topic. That means we have to be smart enough to make the right connections to the fluctuating grid. And this in Germany, with the energy Wende or the energy transition, it's a huge investment from Germany. I live in Germany already for 7 years. I can guarantee you that the Germans will do it. This is a no-way valve, so that means they will do it. They have deactivated the atomic power plants. Nobody believed that, which were, let's say, bringing 20% of the total generation of electricity in Germany. And now they are going to 10%, and in 10 years, it's 0. And this has to be overcome by renewables. It has to be overcome by photovoltaic. And we could expect in Germany to have something between 30 and 50% of renewables going forward. So how are we going to manage this? It's a lot of data analytics. It's a lot of the right decisions. It's a lot of this really small decisions at the residential area, but also at the nanogrid level. And I will explain that going forward. So we have, with this integration, we're now pushing for the integration of infrastructures. In the end, we have to bring more technology to the grid, because no longer the utilities are the only ones producing energy. No, in the past, you had utilities with the price of kilowatt hour. They pushed the electrons into the distribution through transmission, and you paid. And this was a perfect world, no problems. Now we have integration of renewables. You have wind, you have photovoltaic, you have prosumers, you know that. And of course, this brings a lot of applications with data. For example, on power to gas and also bringing the hydrogen topics and methane gas. We have batteries, deployable batteries in the residential area, and also power to heat with some thermal plants. And of course, this goes completely against what we had in the last years, which was a centralized energy distribution. Now it's a decentralized system. And this decentralized system means more data, more actors, so the consumers, the prosumers, even the small utilities, the municipalities, and this will bring a huge demand. If you have a handheld device and you can control the heating bill by making decisions when you are abroad, this is a huge, this is unthinkable 5 years ago, but you can do it. You can remotely put your house with a preheated, let's say, function to have your house at 22 degrees C when you arrive home. And it was not possible to do that. It will be possible. You will have smart meters, you will have applications for that. In the developed world, for example, in the US, this is what the utilities are already showing. You can make a contract, get the device, and control your house remotely. And this is an example of the supergrid. That means the consumers have no longer to be very much concerned in the supergrid, because the utilities, they will produce, be it hydro or fossil, they will produce the enough power to bring it to the point. The big topic is in the consumer world. This is where things will happen, and this is where all of you come in. We need to be smarter, we need to analyze a lot of data, we need to think about plants in the industry which are close to cities so they can cogenerate. We have to look at small photovoltaic plants. For example, in the Crystal, we have 18% of our electricity produced here. And if every building would have 18% of their total photovoltaic, let's say, capacity to offset, for example, lighting, this will be a huge saving, because you don't really have to do anything. You just have to install it once and maintain it. This is a little bit of a technical thing, but there is a lot of things in the energy grid that we need to do. One is the peak avoidance. That means usually before the supper, there is a peak. People going home, they put the appliances, they cook, everything is on. So we need to balance the grid to make sure that if you spend electricity in the morning to clean your clothes in your washing machine or drying machine, it will be much cheaper, so you program your machine to do that in the morning and not in the evening where everybody is needing electricity. So this is also behavior, but also cost control. We have resilience, very important to have resilience. Just imagine in London, where most of you live, if there would be a cut for 5 minutes, a total cut for 5 minutes. You know, the whole systems will stop. Maybe the water system will not stop, but just think about transportation, all electric. Just think about all the traffic lights. So it's critical that we have 100%, not 99%, 100% reliability on the grid. And this, the utility wants to pay, and also the users. If you say, well, if you go to India, we still have 5 to 6 outages per day in most of the cities. It's impossible to operate in a very, let's say, efficient way. And last but not least is the loss prevention. It's not a case here in the US, in London, but for example, in Latin America, there is theft of electricity. So in Mexico City, it's close to 20%. 20% of all the electricity is taken away by different ways and means. So it's very important to have systems which do not allow that, because in the end, everybody pays. So these are just examples. And we can do this because of data information and analytics. Let's see. Yes. One of the examples I like to give is smart parking. And smart parking, why? Because most people don't use the car nowadays in cities, only when they need. So no one goes with a car in a city just to go around and take a look at the city. So they go to specific places to do specific things. First, it's very expensive to park. Secondly, there's a lot of alternative, let's say, ways of going to places like buses and trams and subways. So whenever you have a car and you want to park in a city, it's because you're going to do something very specific. So you already go with a plan what you're going to do. And this is valid in most of the Western Hemisphere, but also now in Asia. So we are now devising, we are not the only company which is doing this, but we are now devising systems for smart parking. That means before you go to a location, you should take a look at your iPad or your mobile phone and see what kind of parking places are available. And this is easily said, but it's very difficult to do unless you have the infrastructure on the lighting poles with radio frequency ID checks. That means they can check if the car is in or not. They can put that in a central database, which you have an app. And before you go shopping or before you go to the clinic, you should know already, okay, I have a potential parking place as I approach. This looks, okay, this is like a gadget. It's not a gadget. It's millions of parking places. And this will be a huge benefit going forward. We are making some pilots in some cities in Germany, where, as you know, the parking is really expensive per hour. So people accept that as a benefit. So instead of going around, they are trying to get this up. And also the advanced traffic forecast for floating car data. This is very important. Again, we know the domain of traffic lights. We know the device. We know how to connect these devices through the web. And we know how to resolve that in analytics. And for that, we then provide the smart data for that. An example is a smart car demo application that I am showing you here. So you will be able to see in your mobile device which light is on or not when you go to school or when you go taking your kid to whatever, to the doctor. You would be able to see if what is the easiest route, but also with interconnectivity to the smart traffic systems. And this does not mean that it's going to change the traffic in 1 year, but in 10 years, we'll have smart parking. We will have devices we show you which is the shortest way to get there, what is the best way for you to use the traffic routes, independently what they may say to you in these announcements that they use now. And these are just small ideas, but in the end, if everyone is doing that, millions of data are being used. And data doubles, the size of data worldwide doubles every 2 years. So if we are not in, let's say, in a governance of finding ways to get out of this data smart decisions, we will not have a better ecosystem, we will not have smart cities, and this is what Siemens is driving behind. And with that, I leave you with the final slide, which means everything we do in the digitalization world is moved by the Internet of Things. So the Internet really changed the way we do business. In all the business units that we have around the world, it's mandatory to use the power of the web. Consumers are being, even the corporate consumers or corporate customers are being much more connected. And the companies or the small companies, be it small, large, or medium size, which work on data analytics with domain know-how and can bring apps to the market, be it on applications of consumer or in the industrial application, they will be the winners for the next 5 to 10 years. Thank you very much for your attention. So,
Wonderful.
good. Thank you.